Hi. In our final lecture on mechanism design, we're going to talk about how we can use mechanisms to decide whether or not we should fund public projects. Now, when you think about a public project, what we're thinking about is some outlay of funds to buy something from which everybody is going to benefit from it. So a private good would be something like this sweater or a chair or a pen. It's something that just one individual is going to use. If we think about a public project, you think about something like a road or a park where everybody can use it. The example I'm going to use for this particular lecture is just the example of getting a coffee machine for an office. Because if you get a coffee machine, everybody can use it. So one coffee machine can serve a whole bunch of people. So here's the idea. Let's suppose there's three people, and person one would be willing to contribute $40. It's worth $40 to her to have a coffee machine. Person two would be willing to contribute $50, and person three would be willing to contribute $20. So if you add all these things up, you get $110. So they'd be collectively willing to contribute $110, and the machine only cost $80, which is great. But here's the problem. The problem is these values, the 40, the 50, the 20, they're private information. No one knows those before the fact. And so what you've got is you've got a classic case of hidden information. People value the coffee machine some amount, but we'd like to get them to reveal that information so we can decide whether or not to buy the coffee machine. Because it could be that they don't value it enough. That person one values it 20, person two values it 20, and person three values it 20, so the total value is only 60, and the coffee machine costs 80, so it's not worth doing. So the challenge from a mechanism design standpoint is to figure out how do we get people to reveal their hidden information. And so again, it comes down to a question of incentive compatibility. So what we're going to talk about here is a mechanism called a pivot mechanism, and this was designed really by three people, Clark, Groves, and Vickrey. So this is sometimes called the Clark-Groves-Vickrey pivot mechanism. We'll just sort of call it the pivot mechanism. Here's how it works. You only have to pay the marginal amount. So you pay the minimal amount that you would have to pay given other people's bids in order to make the project viable. So if without you, people are willing to pay $60 and it costs 80, then you only have to pay 20. If without you, people are willing to pay $70 and it costs 80, then you only have to pay 10. So the idea is you only have to pay that amount that would make it viable if you threw in that much money. And this creates an incentive for you to tell the truth because it doesn't hurt you to say how much you really value the project because you're only going to pay your marginal amount, whether that's $20 or whether that's $10. So here's formally how the Clark-Groves-Vickrey mechanism works. Each person claims a value. Now their real value is hidden information, but they're going to claim a value. And the whole idea behind mechanism design is to get them to claim their true value. So each person claims a value, and if the sum of those values is bigger than the cost, so if everybody's claiming values that add up to more than the cost, since we're going to share this coffee machine, then we go ahead and do the project. We buy the coffee machine. Now how much do people pay? Well, person one is just going to pay the cost minus the bids of the other two people, the values of the other two people. Or if the values of the other two people are bigger than the cost, person one is going to pay nothing because the project would be done without person one contributing anything. So that's it. That's all there is to the mechanism. Let's see how it works. So let's again go to our example where there's three people. Person one values it at 40, person two at 50, and person three at 20, and the cost is $80. So again, if we add these things up, we're going to get $110. So clearly you'd want to buy the coffee machine because they valued it $110 and it only cost $80. But how do we decide how much each person should pay? Again, the rule is each person's just going to pay that cost, which is $80, minus the values of the other two people. So if we look at person one, the cost is $80. The other two people added together, 50 plus 20 is 70. So that means person one is just going to pay $10. What we want to figure out is, does it make sense for person one to tell the truth? So if this is the mechanism, should person one say $40, or should they say $50, or should they say $20? Well, let's think. Let's suppose the cost is 80 and person one values it at 40, and let's suppose that they claim a value of 40. So in this chart we're going to assume that they're actually claiming the truth. Let's think through all the different possibilities. So one possibility is the sum of the other people is only 30. Well, if the sum of the other people is 30 and they claim 40, that only adds up to 70, so they're not going to pay anything because the project's not going to get done, and so they're not going to make anything. Now, if the other people, some of their bids is 40 and our person claims 40, then they're going to pay 40 and they're going to break even. They're going to pay $40 and they're going to get a project for $40, so, whether you do it or not really doesn't matter. Let's suppose that some of the others is 45 though. So now the others' bids or values add up to 45. This person claims 40. They only have to pay 35, right? Because 45 plus 35 adds up to 80, which is our cost. And so on net, they're going to come out 5 ahead. And then finally, let's suppose that some of the others is 90. Well, now, if their claim value is 40, they're not going to pay anything because the sum of the others is above 80, so they're not going to pay anything, and they're going to come up 40 ahead. So if they claim their true value, sometimes the project doesn't get done, sometimes it gets done and they're indifferent, sometimes it gets done, they make a little money, sometimes they don't have to pay anything. Well, now let's suppose they decide to cheat a little bit and to claim a value of only 30. So they're going to say, oh no, it's only not 40, I'm going to lie, I'm going to shade. Well, now if the sum of the others is 30, the project doesn't get done, and they don't pay anything because the project isn't done. If the sum of the others is 40 and they bid 30, again that adds up to 70, so that's less than the cost, so the project doesn't get done. And if the cost sum of the others is 45 and they claim 30, that's only 75, so the third time the project doesn't get done. But in the case where the sum of the others was 90, then the project gets done and they don't pay anything. So if you compare that to the case where they tell the truth, they're worse off in these two cases. Because when the sum of the others is 45, if they'd have told the truth, they only would have paid 35 and they'd have come out 5 ahead. But when the sum of the others is 45 and they say 30, that only adds up to 75 and the project doesn't get done and they're worse off. They're getting nothing when they could have gotten a +5. So it seems pretty clear you don't want to underclaim, because if you underclaim, the project could not get done in cases where you'd like to get done. What about overclaiming? Well, let's think. Suppose the value is 40. Now I claim 50. Well, if the sum of the others is 30 and I claim 50, 50 plus 30 adds up to 80, which is the cost, that means I'm going to have to pay 50 and I'm out 10. Now in the other cases, I'm going to pay only 40 or less, so I'm just the same as if I told the truth. But in this one case, I'm worse off. So what we see is, if I look at the 3 cases, where I tell the truth, where I get 0, 0, 5, and 40, where I understate, I get 0, 0, 0, 40, and when I overstate, I get -10, 0, 5, 40. What you see is, I'm best off telling the truth. So what the Clark-Vickrey-Groves mechanism does, which is fantastic, it's a way to induce people to tell the truth. So this is, again, what we call incentive compatibility. Each person has an incentive under the mechanism, again, provided they're rational, to give their true value. So that's great. It's totally great. And you think, wow, this is a fantastic mechanism. And let's see how it plays out. Let's suppose there's a case where person 1 has a value of 30, person 2 has a value of 30, and person 3 has a value of 30. So the other 2 people have values of 60. The total cost is 90, so that means person 1 is going to pay 30, person 2 is going to pay 30, and person 3 is going to pay 30, for total revenue of 90, which is great. It costs 90, and we're going to get revenue 90. So this mechanism not only gets people to truthfully reveal, but in this case, it actually raises enough money to pay for the project. Now notice that's not always going to be true. Let's go back to our example of 40, 50, and 20. In this case, how much is person 1 going to pay? Person 1 is going to pay 80 minus the sum of the other 2 people's bids, which is just going to be $10. Person 2 is going to pay 80 minus the sum of the other 2 people's bids, which is 1 and 3, which is $60, so they're going to pay $20. And person 3 is going to pay 80 minus the sum of the other people's bids, but that's 90, so the most you can make, you can't make someone pay negative amount, so they're not going to pay anything. So in this case, the total revenue is only $30. So now we have a problem. We have people to truthfully reveal. Everybody gives their true value, but we don't raise enough money to pay for the project. So to pay for the project, we have to have some other way of paying for the project, possibly taxing people. But if we tax people, that could cause them to change their value assessments, because the thing is now they have less money than they had before. So what we see is the Clark-Vickrey mechanism works sort of, like we have some other way of funding the project, but it doesn't work perfectly because it's not balanced in the sense that it can't fully pay for the project. So you can say, okay, what would we like a mechanism to do? Well, in this public project setting, we'd like it to be efficient. By that I mean we'd like it to be the case that you always get the project if it's worth it. So you only do the project if it's worthwhile, so you get an efficient outcome. You'd like it to be the case that it makes sense for people to always join, so you're not coercing people into doing it, like you have to join if you don't want to. You'd like it to be incentive compatible, so that people tell the truth. And then finally, you'd like it to be balanced, you'd like to be able to pay for the project. What you can show is that that's impossible. So there's no mechanism that'll do this. So what you can do is you can sort of do second best. You can sacrifice one of these things. And the thing you can sacrifice in the Clarke-Gross victory mechanism is that it's balanced. Now there's other mechanisms that sacrifice other restrictions in order to get this to work. So they'll be balanced, but they won't necessarily satisfy the condition that no one's coerced to join. It could be that you have to join the project, and sometimes you end up worse off than if you said, I'm not even participating at all. So what we learn from mechanism design by writing models where we say, okay, here's the values that people have, and think about how we induce them to tell the truth, you learn what it's possible to accomplish and what it's not possible to accomplish. Okay, so when we think about mechanism design, there's really sort of, in some sense, two fundamental issues we're trying to overcome. One is hidden actions. We may not see what people do. So what we'd like to do is write down incentive structures and information structures so that we induce people to take the right actions. Because we can't see what they're going to do, so what we'd like them to do is somehow have incentives so we know they're going to take the actions we want. Second thing we use mechanisms to overcome is hidden information, just like we saw in this public project case or in the auction case. We don't know people's values, so what we'd like to do is we'd like to create a mechanism where people truthfully reveal their values and where we get outcomes that are desired outcomes. So in the case of an auction, we sell it to the person who values it the most, and in the case of a public project, we undertake the public project if it's worth doing. All right, so that's mechanism design. It's really interesting. It's a way to use models to try and design institutions so they're more efficient. Now, one thing we saw, though, and I want to be really careful, is most mechanism design assumes people are rational. But when we talk about auctions, and sometimes we saw that if we don't assume people are rational, we maybe get slightly different implications of what we should do. So, for example, we had the revenue equivalence theorem that said it doesn't matter what auction you use, you're going to get the same outcome in each case. But we saw that if we have a different model of human behavior, some auction mechanisms might be preferred over others. So depending on how sophisticated people are, we might want to use a different auction mechanism. The same goes for these public project mechanisms. When you think about mechanism design, what you can do is start out as a benchmark by assuming rational actors and think, if everybody could fully figure this thing out, what would we get? Then you can use your judgment and say, well, let's now try for some more realistic models of how people behave and see how these same mechanisms will hold up. Again, having a model, though, is going to be really useful here because it allows you to think through all the implications of the decisions you're making when you design those institutions. All right, thank you.